I save my screen. We're a VOD store. Board. Creator dashboard, content, video producer. Oh, I have that. Okay, nice. At least. Alright. Let's get started on the road. Okay. Um so today we're gonna be doing two-sum. If you guys were here for didn't want day one, I am doing the neetcode 150 problems. I'm going through them by order of difficulty. Do all the easy problems first, and I'm back at mediums. And so yeah, yesterday we finished contains duplicate invalid anagram. So today probably do two-sum, maybe something else. Yeah. Alright, so we have two-sum. Is very, very simple problem. Very straightforward problem, actually. Probably a better way to put it. You are given a list of integers, and a target. You want to return the indices of the two numbers such that they add up to target. So every list will have. Can't use the same element. You're gonna return the answer. So, my mind here jumps immediately to first sorting the list, and then using two pointers to kind of collapse in from the left and right until we do get pairs or the pair. It is faster than n squared because we don't need to iterate through every single. This is really just O of n? Oh, n log n because of sorting, obviously. But let's, I guess, put this into English prose. Sort the list iterate through the sorted list, then use 2 pointers from the left and right to and if the sum of the values at the of sum of the values those indexes are is less than target increment just less than target, we do left plus equals 1, right, versa for some should be right plus equals 1. Time complexity is under 10, and so it's pretty simple. For we can iterate through the sorted list. We can iterate through the list and sort at the same time. In sorted, enumerate. Actually, let's just do this. I kind of use enumerate for everything. Need to necessarily. Actually, sorry, I'm just thinking if there's any issues with like the number of times I have to iterate through the list. I don't think there is. I mean, actually, I don't even need to. I mean, I guess it's just easier for me to use enumerated or enumerate, because if I just use index, I can just do for I in range nums without even needing to sort it first. But then I need to sort it inside and then get I of sorted nums. So I can just do that here. So in for IA in enumerate sorted nums, we have 2 pointers left to right, 0 and length of nums. This one there. So now we have the 2 pointers at the left and the right. For I mean, because okay, what I'm thinking about right now is that I don't really need a for loop isn't really like I guess perfect for this situation. I think it will work because I think no matter what we're gonna get to the answer in the amount of times that we find or for the amount of times that we iterate through list. But I don't know. I'm thinking about maybe using a while loop instead. But I guess it's fine. I think a for loop. I think instead of overthinking it, let's just solve it. So if I guess uh hmm. I think we're gonna have to access array. So n is going to equal sorted. I don't know if we can do this actually. I'm assuming we can. Maybe we just have n here, right? So if n at L is less plus n at R is less than target, then L plus equals 1. Else if n, I mean, I guess we can just get the sum of here. So we can get this S equals sum and L plus n at R. If S is less than target, is incremented by 1. Else if S is greater than target, R plus equals 1. And else the only other case here would be if it matches, we'd return n L Okay, I think that should work. Yeah. So basically, sorted sums. Right through that. Yeah, we don't even need a for loop. Yes. Yeah, we don't even use I or A at all. That's what I was really thinking. Like, yeah, I'm so OS is not equal to targets. Oh my gosh, I'm literally like thinking myself into a hole here. Like, there's really no need for me to overthink. So I guess right off the rip, if S equals target and return and oh gosh and R. What does it return? This. Else, so ls target. This is less than target. Increment left. Also, if it's greater than target, decrement to right. Good catch by me. Otherwise, it means that they are caught. I feel like I messed up. Why is it taking so long? What? Oh, it's because I'm not so stupid, bro. S equals N L plus. It's because I'm not at it. Silly me, silly me. Holy shit, I'm dumb. I don't even. Oh gosh, I'm actually like, oh. You just have to return the indices. So L R. Same thing here. L R. I'm a little bit. Yeah. Oh my gosh. Okay. I don't know. I do know. Basically, what is going on is I mistakenly assumed that the indices, we need to return the indices of it in its original, like, arrangement, and I didn't put it, like, sorted it, do that. So, you know, guess I'm stupid. Um, all we can do here is just find the indices, index. We can find the index of the element because we know there is exactly um their index of. This is such a sloppy index. So okay, so do nums index n o nums dot index and r. I suck at talking. This definitely. I'm so like. This definitely like super optimal and for index. let's start over. Um, wow, I can't believe that stuck. Uh, solve this problem like 10 times. Guess I want to find a solution a little bit more elegant. Frustrating. Alright. So let me take a look at the problem again. We have an array called nums. We want the indices of the two numbers in that list. So each list has exactly one solution. Can't use the same element. Okay. So order. I mean, I would assume that could be a hint using it in any order, but let's see. If I okay, I just kind of thought of something will work, but I'm thinking like, what if we just have one pointer, right? And we go through the list of numbers and we subtract that index from target. We check if the other one exists. If it does, we found it, we can return it. That makes sense. And we can start from the back and we can use index to find the first index. Oh, okay. Let's try that. So what we need to do is we don't even need to sort it. Oh, we can just, oh, wow. Wait, this is really cool. So we can have a right pointer starting at length of list, or sorry, length of nums, length of the list, -1. And what we're going to do with that is while I guess we'll true, we can check so we want to see if a number is, it's not, we want to see if target minus r is exists. Index of time complexity. O of n. Ah, that's very cool. So our solution is actually O of n. Isn't that crazy? Isn't that crazy? All right. So while true, we're going to subtract r from our target, or n at the nums at r. So I guess we have not sum, if is equal to target minus nums at r, and then we're going to check if it exists, that means it'll exist. So we're gonna do nums at diff, nums dot index diff, right? So if that exists, then we can just return diff, not the diff, but nums dot index diff and r. Otherwise, we just r minus equals 1. Return none. I mean, it's never going to hit return none. In nums. In keyword Python time complexity. Hey. All then. Everything's all then, I guess. Oh, we don't even need if the difference isn't nums. Dang! Wow! Great job. Actually really impressed myself. I don't think I've ever done this before. But hey, what a solution. I guess to explain my thought process one more time, I guess for practice, is we are going to start from the end of the list and we're going to subtract that value in nums from target. And we're going to check if it exists in nums, then that is the pair that we're going to work with. So that would be r and then the difference. So we just have to find the first index of it. Since we're starting from the back, it won't be the same as r, because this will find the first index. And we're going to return that index and the right index. If we don't find it, we're going to subtract 1 from r, and we're going to like keep moving backwards through the list. Yeah, submit it. Oh, wow, that's everything except for oh, I see. So I guess the only thing we need to check if not, yeah, basically what's happening is getting the same index. So we just gotta make sure it's not the same index. It's not equal to r. Bang, return this. Use a test case. Sorry. Slow down. Slow down. Alright, nice. Hey, O of N. Good job. Me. Use a hash map. Yeah. I feel like my solution's pretty chill. It's O of N. It's faster than O of N squared for sure, right? So yeah. Brute force solution here is obviously go through literally every permutation. Word per combination. It's one of the two, right? So, but obviously very inefficient word. It's a lot more efficient. I defaulted to sorting it because I guess for some reason I forgot that we have to return indices. um instead of like the actual number in the list. But dang. Alright, well, good job me. I solved two sum once again. Go. Alright. That's about 30 minutes. I know I spent a little time. I spent a little time for this stream on, but whatever. Alright, thanks for watching. Cat, but successfully we have now completed. Problems completed 3. Job. Oh. Oh, it's on me. Whatever. Thanks for watching. Goodbye.